Hey everyone, and welcome to our deep dive. We're going to be taking a deep dive into the world of data-intensive applications.
Yeah.
We're really excited to crack open this book, Designing Data-Intensive Applications by Martin Kleppmann.
It's a fantastic book.
Yeah, it looks really dense. I've started reading it. We're going to do our best to kind of extract the core principles,
Yeah.
for building these systems. We're talking about systems that need to be reliable, scalable, and maintainable. So that's our mission here
Yeah.
with this deep dive. It's basically to figure out how to build these things. I mean, these are the systems that power,
Huh.
all of the apps that we use every day, everything from, social media to online banking.
Oh, yeah. It's really, one of the things that's so fascinating about this field is how quickly it's evolving. Just think about the sheer amount of data that we generate today. It's mind-boggling.
It is, and it's only getting, more and more data. I mean, that's the thing that's so crazy about it.
Right.
Is that, it's just this exponential growth. And so these principles that we're going to be talking about,
Yeah.
they're not just for like super techie people.
Yeah.
You know what I mean? This
Yeah.
is becoming like essential knowledge for anyone who works with data. Whatever your technical background is.
Absolutely.
This stuff is becoming so important. So let's kind of break down those qualities. You said reliable, scalable, maintainable.
Yeah.
So the book really emphasizes how crucial those are.
Yeah.
And I think that makes sense. I mean, we all rely on these apps working all the time.
Exactly. And I think the easiest way to think about reliability is a system that's just dependable. So if there's an error, it's not going to crash, it's not going to lose data, it's not going to give you the wrong results. And this is really critical when you're talking about things like financial transactions or, personal data.
Makes sense. So reliability is about building trust, basically.
Absolutely.
So what about scalability? What does that mean?
So scalability is about handling growth gracefully. So think about an app that suddenly gets 10 times more users. A scalable system can just adapt to that without, breaking a sweat, and it can ensure, a smooth experience for everyone, even at those peak times.
So it's like building a system that can like flex its muscles
Yeah.
when it needs to. But that can't be easy, right? To build something that is both reliable and scalable.
You're absolutely right. There's often trade-offs.
Yeah.
So, for example, you might add more servers to handle increased traffic. But then that potentially introduces new points of failure.
Right.
So suddenly your system might be less reliable. And so finding that kind of sweet spot between these qualities is one of the big challenges in designing data-intensive applications.
Got it. And then finally, maintainability. So I get that it's not just about building the system. It's about, making sure that it can be like managed and evolved over time.
Yeah.
What does that really mean in practice?
Yeah, absolutely. So maintainability is about making life easier for the people who are going to keep this system running smoothly. So that's, your engineers, your operation teams, things like good abstractions, clear insights into the system's health, effective management tools. These all contribute to a more maintainable system. And ultimately what that means is that, you reduce those long-term costs and those headaches. It's about making the system a joy to work with,
Right.
not a constant source of frustration.
Right.
Yeah.
Yeah, like you don't want to dread going in and like trying to make a change to it.
Right.
It should be like a nice kind of, like well-organized workshop where you can find the tools you need and you know how to use them.
Exactly.
That's great. So the book talks about a lot of, different data models, the impact that these data models have on application development. And I found it interesting how the book talks about, the dominance of the relational model for so long. Then you have like this rise and fall of things like object databases and XML databases. Can you talk a little bit about that?
Yeah, so I think what's important to understand is that there's no one-size-fits-all solution when it comes to data models.
Right.
Each one has its own strengths and weaknesses, and choosing the right one can have a huge impact on, how you actually build your application.
So it's like having different tools in a toolbox, right?
Exactly.
You wouldn't use a hammer for every job.
Exactly.
So like when would you use like a relational database versus like a document database?
So if you're looking at a relational database, you're probably thinking about structured data. So that's, your typical SQL databases, your MySQL, your PostgreSQL. But then if you have data that's a little bit more flexible, it's changing more, you might want to consider a document database like MongoDB.
Okay.
And then you have things like graph databases, which are perfect for relationships.
Yeah.
So if you're thinking about a social network or a recommendation system, those are perfect examples of where you would use a graph database. The key is to choose the model that best suits your needs.
Okay, that makes sense. So once you've chosen your data model,
Yeah.
how do you actually like interact with the data? So I'm curious about query languages and how they work.
Yeah, so query languages are basically how we talk to databases. We tell them what data we want to retrieve, how we want to manipulate that data. And the book talks about two main approaches: imperative and declarative.
Okay.
So with the imperative approach, you're basically giving step-by-step instructions. You're
Right.
telling the database exactly how to fetch the data.
Okay.
But then declarative languages are more about stating what you want
Okay.
without specifying how to get it.
So it's kind of like giving someone directions versus telling them the destination.
Exactly. And so, no, is one approach better? Not necessarily.
Yeah.
It really depends on the situation. Imperative languages give you more control, but declarative languages like SQL can be a lot more concise. They're much easier to read,
Yeah.
and they can be optimized by the database system
Right.
without you having to rewrite any queries, which is a huge advantage.
Yeah. So it's like having like a smart assistant that can kind of figure out the best route for you.
Exactly.
That's cool. So let's get into like the nuts and bolts of data storage.
Yeah.
So the book has this really interesting analogy about appending data to a log file,
Yeah.
and it's surprisingly efficient.
Yeah, it is.
So can you
Yeah.
talk a little bit about that?
Yeah, so the log is like this fundamental concept that underlies a lot of databases, and it's this really simple idea. It's an append-only file,
Yeah.
so you just keep adding new data to the end. And this is surprisingly efficient
Okay.
because appending to a file is super fast,
Yeah.
and a lot of databases use this kind of log-structured approach internally.
So it's kind of like keeping a running diary of all the changes.
Exactly.
But then how do you find like specific information
Yeah.
efficiently in this constantly growing log?
Yeah, that's where indexes come in.
Yeah.
So indexes are like these signposts that can help you quickly locate specific data within a large data set.
Yeah.
Think of it like a table of contents for your data. Without indexes, searching for information would be like looking for a needle in a haystack.
Right.
So they're really important.
So indexes are like having like a fast track to the data you need.
Absolutely.
Okay. But I imagine there are different ways to create indexes.
Yeah.
Does the book talk about that?
Yeah, there are all these different indexing structures, and each one has its own trade-offs. So, for example, a B-tree,
Uh-huh.
which is a very common indexing structure
Yeah.
that's really great for finding specific values or ranges of values.
Yeah.
And you see these in a lot of popular databases like MySQL and PostgreSQL. Then you have things like log-structured merge trees, which are optimized for write-heavy workloads. So those are used in databases like LevelDB and RocksDB. Understanding these different structures
Yeah.
can really help you pick the right tool for the job.
So it's like choosing the right vehicle for a journey. You know, if you need speed, you get a sports car. If you need to haul a lot of stuff,
Exactly.
get a truck.
Yeah.
Okay. So speaking of speed, the book dives into performance optimization, which is obviously critical for, any app that anyone actually wants to use.
Absolutely nobody likes to wait for
Right.
a slow app.
Exactly.
Yeah.
So one of the key insights that the book highlights is that response time. So how long it takes for an application to respond to a request.
Yeah,
It isn't just a single number,
right.
a distribution of values.
Absolutely.
So it's not just like the average speed, it's also like how consistent is that speed?
Exactly.
So what's the best way to actually measure that?
So one of the things that the book talks about is using percentiles.
Okay.
So percentiles give you a much more complete picture of performance because they show you the response time at different thresholds.
Okay.
So for example, the 95th percentile response time tells you that 95% of requests
Okay.
are handled within that time frame.
Okay.
But that also means that 5%
Right.
could be much slower.
Got it.
And that can really impact user experience.
So it's like understanding not just the average grade in a class, but also like the distribution of grades.
Exactly.
Okay. Does the book give any like real world examples of how these percentiles are actually used?
Yeah, so it mentions service level agreements or SLAs,
Right.
which often specify acceptable response time thresholds.
Yeah.
And they use percentiles.
Okay.
So this really helps set clear expectations
Okay.
for the performance of an application.
Yeah. So it's like a performance contract.
Exactly.
Cool. So the book also talks about understanding load parameters.
Yeah.
So when you're designing these scalable architectures, can you explain what those are?
So load parameters describe the expected usage patterns of your application.
Okay.
So things like the number of requests per second
Mhm.
or the size of the data that's being processed. And accurately estimating these parameters is really important
Right.
because if you overestimate them, you might end up building a system that's way more powerful than it needs to be.
Right.
And on the flip side, if you underestimate them, you might run into performance issues down the line.
So it's like building a bridge that's either way too strong for the traffic it needs to handle or it's way too weak.
Exactly.
Got it. And I imagine this is especially important for, startups
Yeah.
that are, growing really quickly and they need to be adaptable.
Absolutely. Startups need to be able to, iterate quickly and
Mhm.
respond to changing demands.
Yeah.
And, if they over-engineer for scalability too early, that can be a costly mistake.
So being able to scale is important, but it's not the only thing that matters.
Absolutely not.
And the book makes a strong case for the importance of maintainability, which, I think is often overlooked.
Yeah, it's often neglected, but it has a huge impact on the long-term costs of a software project
Yeah,
and the success of a software project.
totally. Like a system that's difficult to maintain is just a burden
Oh,
on,
yeah.
on the team, and it just slows down development and increases the risk of errors and all sorts of stuff.
Absolutely. It's like having a car that's constantly breaking down.
Yeah.
Yeah. You end up spending more time and money on repairs than you do actually enjoying the ride.
I like that analogy.
Yeah.
You just want something that's dependable and that you can, work with.
Yeah.
So maintainability is about more than just fixing bugs.
It is. It's about making the system easy to understand,
Yeah.
easy to modify, and easy to adapt to new requirements.
Right.
So using clear abstractions, providing good visibility into the system's health and having those effective management tools.
It's like having a well-organized house.
Yeah.
Where everything has its place and, where to find things.
Exactly. And now let's talk about how data is actually represented
Okay.
within these systems. So the book gets into, different encoding formats. Think about these as different languages for data.
Okay. So it's about like how the data is like structured,
Yeah.
like packaged, right?
Exactly.
So I know some common formats like, JSON and XML.
Yeah.
Are those what we're talking about here?
Yeah, absolutely. So those are really popular because they're human readable.
Right.
And they work well across different systems. But, as the book points out, there are some downsides.
Okay.
They can be a bit verbose, which means larger file sizes.
Oh.
And, that can impact performance, especially when you're dealing with massive amounts of data.
So what are the alternatives? So if we need to handle lots of data quickly, are there like more streamlined options?
Yeah, so the book talks about binary encoding formats like Thrift, protocol buffers, and Avro. And these are much more compact.
Okay.
And they're more efficient, especially for large data sets.
Got it.
You can think of it kind of like a shorthand for data
Okay.
that computers can process more quickly.
So it's like choosing between writing a message in long form
Yeah,
or using like abbreviations and symbols.
exactly.
Got it.
Mhm.
And do these binary formats also come with schemas, like a way to define what the data actually means?
They often do. So you can think of a schema as a blueprint that defines the structure of the data. And this makes it a lot easier to ensure that, different systems can interpret the data in the same way.
Right. So it's like having like a shared language for the data.
Exactly.
Okay. But wouldn't that make it harder for like humans to read and understand the data directly?
Yeah, that's a valid point. Binary formats are not as human readable,
Right.
but there are tools that can help decode them when you need to.
Okay.
But the trade-off is that you gain that efficiency in storage and processing.
Got it. So it's kind of a balancing act between like human readability and machine efficiency.
Exactly.
Okay. So let's talk about how data actually moves between different parts of a system. So I know there's different ways to do this, like APIs and messaging systems. What does the book kind of highlight here?
Yeah, so the book talks about, different approaches to data flow, and one of the key distinctions it makes is between synchronous and asynchronous communication.
Okay.
So in synchronous communication, like a typical REST API call, one process sends a request, and then it waits for a response before it can do anything else.
Okay.
It's kind of like a direct phone call. You have to wait for the other person to pick up before you can talk.
That makes sense for things where you need an answer right away.
Right.
But what about those cases where you don't need an answer right away? What's the alternative?
Yeah, so that's where asynchronous messaging comes in.
Okay.
And these systems use, intermediaries called message brokers or message queues.
Okay.
And they kind of act like a postal service
Okay.
for your data. So one process can send a message without waiting for a response.
Yeah.
And the message broker will just deliver it to the recipient
Okay.
whenever they're ready.
So it's like sending a letter. You drop in the mailbox and we'll get there eventually.
Exactly.
What are the advantages of using a system like this?
Well, there are several, especially for building resilient and scalable systems. So, for example, if the recipient isn't available,
Right.
the message broker will just hold on to the message and deliver it when they're back online. So it makes the system a lot more tolerant to those kinds of failures.
Right. So it's like having a safety net for your data. That's really cool.
Mhm.
And it seems like this would be really useful for handling like large volumes of data
Oh, absolutely.
without slowing things down, right?
Yeah.
Because you don't have to wait.
Asynchronous messaging lets different parts of a system operate independently
Right.
and at their own pace.
That's really neat. And I think the book dives into some specific message broker technologies, right?
Yeah. It talks about things like Kafka and RabbitMQ,
Okay.
which are really popular choices.
So it's about choosing the right delivery method for your data
Right.
based on what you're trying to do. Okay. Let's talk about replication,
Yeah.
which is a concept I've heard a lot, but I don't fully understand. So why is it so important in data-intensive applications?
So replication is really crucial for fault tolerance
Okay.
and for high availability. In simple terms, it means creating copies of your data
Okay.
and storing them on multiple servers so that if one server fails, the system can keep operating.
Got it.
It's like having backups of your important files.
Look at insurance policy for your data.
Exactly.
Okay. Are there different ways to do replication? Does the book go into the details?
It does. So it starts with leader-based replication, which
Okay.
is a pretty common approach where you have one server acting as the leader. That's the one that accepts all the right operations.
Okay.
And then the other servers act as followers.
Uh-huh.
They replicate the leader's changes,
Okay.
and they can serve read requests.
So it's like having a primary copy of a document
Yeah.
and then like distributing copies to other people for reference.
That's a great analogy.
Okay, cool.
Oh.
And does the book explain like the process of how do you set up new followers?
It does.
Like how do you make sure they can catch up without missing anything?
It gets into that. It talks about concepts like log sequence numbers and bin log coordinates.
Wow. I don't know what those are, but
Yeah, those are important.
it sounds complicated.
They are, but they're essentially mechanisms
Yeah.
for keeping those replicas in sync.
Okay, so it's not just like copying the data. It's like making sure those copies stay up to date.
Ex-
But I imagine there are challenges
Yeah.
with this kind of approach, right?
Absolutely. So one challenge is replication lag. So that's the time it takes for changes made on the leader
Okay.
to be reflected on the followers.
So it's like reading like an outdated version of a document,
Exactly.
and that could obviously cause problems.
Yeah, you can imagine if you read from a follower
Yeah.
that hasn't caught up yet.
Are there ways to minimize that lag?
There are, but it's often a trade-off between consistency and performance.
Right.
So the book really delves into those trade-offs, and it encourages you to think critically about,
Yeah.
which ones are acceptable
Right.
for your specific application.
It's like choosing between having the absolute latest information,
Right.
even if it's delayed,
Yeah.
or having slightly outdated information.
Yeah.
But that's available immediately.
Exactly.
I'm also curious about what happens if the leader server fails. So does the book address that?
Yeah. So the book talks about the concept of failover, which
Yeah.
is the process of switching to a follower
Right.
if the original leader fails.
Okay.
And this can be automated,
That's cool.
to minimize downtime.
Right.
But it also introduces, the risk of data loss.
Yeah.
So if some rights haven't been replicated before the failover, you could lose data.
So it's like this delicate balancing act between like making sure things are always available,
Yeah,
but also like minimizing the risk of losing stuff.
exactly.
Are there like alternatives to this leader-follower approach?
There are. The book talks about other replication methods.
Okay.
So things like multi-leader replication, where you actually have multiple servers
Okay.
that can accept writes, and then leaderless replication,
Oh.
where any server can accept writes.
Okay, so those are like much more distributed.
Yeah, they're more decentralized.
Yeah.
Yeah.
So what are the advantages of those kind of methods?
Well, they can offer better performance and resilience in some situations. So, for example, multi-leader replication can be useful for geographically distributed applications.
Okay. So if you have users all over the world,
Yeah.
you might have a leader in each region.
Oh, wow.
Leaderless replication
Yeah.
can provide higher availability because the system can keep working
Yeah.
even if some servers are unavailable.
Right.
What?
It seems like it would be much more complicated
Yeah,
to
absolutely.
manage those, right?
Yeah, managing write conflicts becomes a lot more complex
Right.
when you have multiple servers accepting writes.
So it's like having to negotiate and reconcile different versions of a document
Exactly.
when multiple people are editing it at the same time.
Yeah.
That sounds tricky. So does the book dive into those challenges at all?
It does. It talks about different conflict resolution strategies,
Okay.
ranging from simple things like last right wins
Yeah.
to more sophisticated techniques
Okay.
where you actually have like custom conflict resolution logic.
So it gets pretty complex.
It can,
Yeah.
and these challenges are made even more difficult by the fact that time
Right.
isn't always reliable in distributed systems. Because, like, if you have multiple servers,
Yeah,
you don't know which one is doing things.
exactly. Clocks on different servers might drift slightly.
Right.
You might have network delays that introduce uncertainty.
So it's like trying to reconstruct a sequence of events
Yeah,
from multiple witnesses who
exactly.
all have slightly different perspectives.
Yeah, and so the book really emphasizes the importance of understanding these time-related issues
Okay.
when you're designing and debugging
Yeah.
distributed systems.
Okay, so time is a much more complex concept in these systems than we might think.
Yeah,
So, okay, let's talk about another aspect of scalability
okay.
that the book mentions, which is partitioning.
Yes.
Can you explain what that is and why it's important?
Yeah, so partitioning is a technique for splitting up a large data set
Right.
into smaller chunks called partitions, and these partitions can be distributed across multiple machines.
Okay.
So it's kind of like dividing a large book into chapters.
So instead of trying to store everything in one place,
Spread it out.
you spread it out strategically.
Strategic. Okay, but how do you decide, like, how to divide the data?
So there are different partitioning strategies, and
Okay.
each one has its own strengths and weaknesses.
Okay.
One common approach is key range partitioning,
Okay.
where you basically sort the data by a key
Okay.
and assign it to different partitions based on ranges of key values.
So it's kind of like organizing a library by, like, book titles.
Exactly.
So like all the books within a certain alphabetical range are grouped together.
Yeah, and this works well for range queries,
Okay.
where you're looking for data within a specific range.
Got it.
But it can lead to hotspots.
Like if certain titles
Yeah, if certain key ranges are accessed a lot more frequently.
are more popular than others.
Exactly.
Right. So it's like all the popular books are clustered in one section of the library.
Yeah, and so that creates a bottleneck.
Right.
So are there ways to address that?
Those are there.
There are. Another approach is hash partitioning.
Where you use a hash function to distribute the data more evenly across partitions regardless of the key values. So this is more like randomly scattering books throughout a library.
Okay, so it's like a more randomized approach to kind of spread the load more evenly. But each approach has trade-offs.
Absolutely.
Right.
The choice of partitioning strategy depends on the specific access patterns of your application
Okay,
and how you plan to query the data.
got it.
So the book really encourages you to think carefully about those factors before you make a decision.
So it's not one size fits all. You have to choose the right one for your specific needs.
Exactly.
Okay. So let's move on to transactions, which I think are considered like one of the cornerstones of data management.
Yeah, absolutely.
So can you explain what transactions are and why they're so important?
So transactions are this really fundamental concept for ensuring data integrity,
Okay.
especially when you have multiple operations that
Yeah.
need to be performed together as a single unit. So they group together a series of operations and they
Okay.
make sure that either all of them succeed
Okay.
or none of them do.
It's like making a multi-step move in a board game.
Exactly.
You can't just like stop halfway through.
You can't just stop halfway through.
So what makes transactions so reliable?
So transactions are governed by what are known as the AC properties:
Okay.
atomicity, consistency, isolation, and durability.
Wow. That's a lot.
Yeah. It sounds very technical, but
Yeah.
essentially what they do is they guarantee that transactions behave in a very predictable and reliable way,
Okay.
even in the face of concurrency and failures.
Okay. So those are like some serious guarantees. Can you kind of break down what each of those actually means?
Yeah, absolutely. So atomicity ensures that a transaction is treated as a single indivisible unit of work.
Okay.
So either all of its operations are completed successfully
Okay.
or none of them are. Consistency means that a transaction brings the database from one valid state to another. It maintains data integrity. Isolation ensures that concurrent transactions,
Yeah.
so transactions that are happening at the same time,
Yeah.
don't interfere with each other.
Okay.
And durability guarantees that once a transaction is committed,
Uh-huh.
its changes are permanently saved even if the system crashes.
Okay.
So these properties work together
Yeah.
to create a really robust...
Yeah. It's like having a safety net
Exactly.
for your data. But I imagine there are like different ways to implement these properties, right?
You're absolutely right. Different databases
Yeah.
implement these properties
Yeah.
to varying degrees. So some offer very strong guarantees.
Right.
Others might prioritize performance over strict consistency.
Okay.
And understanding these nuances is really important
Yeah.
for choosing the right database.
So it's about understanding the trade-offs
Exactly.
and choosing the level of consistency that's right for your needs.
Exactly.
Okay. Does the book dive into those trade-offs at all?
It does. So it talks about the concept of isolation levels.
Okay. And those define the degree to which concurrently executing transactions can interfere with each other.
So stronger isolation levels provide more guarantees,
Yeah.
but also like could slow things down potentially.
Exactly. And weaker isolation levels might offer better performance,
Okay.
but then you have an increased risk of data inconsistencies.
Got it. So it's like choosing between having a really strict referee
Yeah.
who enforces all the rules meticulously
Ah.
or having a more lenient referee
Yeah.
who's more flexible but might let some things slide.
And the book gives some really good examples of, issues that can arise with weaker isolation levels.
Yeah.
Things like dirty reads,
Hmm.
non-repeatable reads,
Okay.
phantom reads.
Wow. That sounds scary.
They can be.
Okay. So let's shift our focus to another aspect of building reliable systems, which is fault tolerance.
Okay.
So what does the book say about that?
So the book has this really refreshing approach to fault tolerance
Mm.
where it acknowledges that,
Yeah.
in a distributed system.
Failures are going to happen.
Yeah.
It's inevitable.
Right.
Network connections can drop, servers can crash, disks can fail.
Right. Like things are going to go wrong.
Exactly. And so instead of trying to prevent all failures,
Yeah.
the focus should be on designing systems that can handle those failures gracefully.
Okay. So it's not about if it's going to fail.
Right.
It's about when it fails.
Exactly.
Okay.
So you want a system that can detect those failures, recover from them,
Yeah.
and continue operating with minimal disruption.
So it's like having a backup plan
Yeah.
for your data.
Exactly like having a spare tire in your car.
Right, right. You might not need it often,
Yeah,
but when you need it, you really need it.
exactly.
But what about like those really unusual failures, like those Byzantine faults that the book mentions?
Yeah, so Byzantine faults
What are those?
are this really interesting category of failures. So
Okay.
in this case, a component of the system might behave erratically or even maliciously.
So it's not just broken. It's
Right.
like,
It could be sending wrong data.
oh, wow.
It could be doing all sorts of unexpected things.
So it's like unpredictable
Yeah.
and potentially dangerous.
Exactly. And so dealing with these kinds of faults requires some special techniques.
Okay.
So, things like using redundant components
So-
and implementing consensus algorithms that can actually tolerate a certain number of faulty nodes.
That's like building in those extra safeguards.
Yeah.
Making
Okay.
the system more resilient.
To those like really unpredictable events.
Right.
Got it. So I want to circle back to something we talked about earlier,
Yeah.
which is the challenges of reasoning about time
Yes.
in distributed systems. And the book really emphasizes this point. And I'm still a bit confused. Like, why is this such a big deal?
Yeah, so it's a big deal because in a distributed system, you don't have a single global clock
Right.
that everybody agrees on.
Yeah.
So clocks on different servers, they might drift slightly.
Right.
And you have network delays
Right.
that can introduce uncertainty. So like, what does that actually mean in practice though?
It means that events that appear to happen in one order on one server might appear to happen in a different order on another server.
So it's like trying to reconstruct a sequence of events
Egs.
from multiple witnesses
Yeah.
who all have like slightly different perspectives.
And so you can imagine these
Yeah.
subtle discrepancies in time can lead to all sorts of unexpected behavior.
Right.
It can be really, really difficult to debug.
So time is not as simple as we think
Yes.
in these complex systems.
Not at all.
Okay. So let's talk about another concept that the book highlights, which is consistency and consensus.
Okay.
These sound like really important concepts for like ensuring data integrity.
Yeah, absolutely. So consistency is about making sure that all the nodes in a distributed system
Ah.
have a consistent view of the data.
So everyone's got the same information,
Yeah,
even if they're accessing it from different parts of the system.
exactly. And consensus is about getting multiple nodes to agree on a single value,
Yeah.
even if some of those nodes fail.
Okay, so consensus is like a group decision-making process
Yeah,
where everyone needs to come to the same conclusion,
exactly.
even if some people are unavailable or whatever.
And these consensus algorithms are used for all sorts of things in distributed systems.
Yeah.
Things like leader election,
Uh-huh.
where nodes need to agree on which one is the leader.
Right.
And then distributed locking, where nodes need to coordinate access
Oh,
to
yeah.
shared resources.
So it's like having a mechanism to make sure that
Yeah.
everyone's on the same page.
Everybody's on the same page. Okay.
Yeah, yeah.
But I imagine these algorithms can be really complex.
Oh, they're definitely not trivial. There are different consensus algorithms, and they all have trade-offs in terms of complexity, performance, and fault tolerance.
You gotta choose the right one.
You got to choose the right one for your situation.
Okay. So let's shift gears a bit and talk about another approach to data processing, which is batch processing.
So how does this differ from like the online processing that we've been talking about so far?
So batch processing is about processing large amounts of data offline,
Okay.
so typically in bulk.
Okay.
And it's often used for tasks that don't require immediate results.
Yeah.
So things like generating reports, analyzing log files,
Right.
or training machine learning models.
So it's kind of like a big cleanup or like a reorganization task
Yeah,
that you can do in the background.
exactly.
Okay, cool. And the book gives a pretty comprehensive overview
It does.
of MapReduce,
Yeah.
which is a really popular framework for batch processing.
Yeah, it's a classic. Yeah, it explains, the core concepts,
Well-
gives you some practical examples.
So MapReduce is kind of like having a specialized team
Yeah.
that can handle those big data crunching tasks really efficiently.
Exactly.
Okay. But are there other approaches
There are.
to batch processing besides MapReduce?
Yeah, the book talks about some alternative frameworks and techniques. So some frameworks offer better performance
Okay.
for certain types of workloads.
Yeah.
Others are easier to use,
Okay.
more flexible. So again,
Okay.
it's about choosing the right tool for the job.
So it's like having a diverse set of tools in your data processing toolbox.
Exactly.
Okay. So let's move on to stream processing,
Okay.
which is a paradigm that's becoming increasingly important.
It is.
So can you explain what stream processing is and how it differs from batch processing?
Yeah, so stream processing is about processing data in real time.
Okay.
So as it arrives,
Well,
rather than in batches.
So it's like watching a live video feed
Exactly.
versus watching a recorded video.
Yeah.
Okay. So what are some like real world applications of stream processing?
We see stream processing used in a ton of different applications.
Yeah.
Things like fraud detection, real-time analytics, personalized recommendations, social media monitoring, IoT data analysis.
Wow. So it's like having this constant pulse on the data.
Yeah.
And you can like make decisions and take action
In the moment.
in the moment.
Exactly.
But I imagine stream processing has its own challenges.
Oh, it definitely does.
Right.
Yeah, the book dives into those challenges, talks
Right.
about things like message delivery, fault tolerance, state management windowing.
So it's about designing systems that can handle this like constant flow of data
Yeah,
without missing a beat.
exactly. You
Right.
don't want to lose any information.
Right.
Yeah.
And does the book talk about any like frameworks or tools?
It does. It introduces several stream processing frameworks that can really help you build
Right.
robust and scalable applications. And these frameworks provide, different features and
Yeah.
abstractions to
Hmm.
make development and deployment easier.
So again, it's about picking the right tool for the job
Absolutely.
based on what you need to do.
Yeah.
Okay, let's talk about data integration.
Okay.
So can you explain what that is and why it's so important?
Yeah, so data integration is about bringing together data from different sources
Okay.
and making it work together seamlessly.
Okay.
So, in a real world application, you're rarely going to find a single database
Right.
that meets all of your needs.
Yeah, you might have stuff in different databases and caches and search indexes and all
Ah.
sorts of different places.
And so data integration is about building those connections
Okay.
between those different data sources.
So it's like having pieces of a puzzle
Yeah.
scattered across different places,
Yeah.
and you need to find a way to assemble them to a complete picture.
That's a great analogy.
Okay.
Yeah, and the book explores different techniques for doing this.
Okay.
Batch processing event streams, change data capture.
So it's about finding the right way to connect those pieces of the data puzzle.
Yeah. And the challenges,
Yeah. What are the challenges with this?
well, you need to make sure that the data stays consistent
Right.
across all those different systems.
Yeah, that sounds hard.
It can be.
Yeah.
And the book, explores those challenges, talks about potential pitfalls,
Okay.
offers some guidance on how to mitigate them.
So it's like making sure that all those pieces of the puzzle fit together perfectly,
Yeah.
even if like some pieces are missing or damaged or whatever.
Yeah, exactly.
Okay. So I'm curious about what the book has to say about the future of data systems.
Oh, okay.
Does it offer any insights into like emerging trends or anything like that?
It does. The book takes a look into the future
Cool.
and highlights some of the key trends and challenges.
Okay, so what does the crystal ball reveal? What are some of the things we should be paying attention to?
Well, one of the key takeaways is that we're moving towards a more unbundled approach to data systems.
What does that mean, unbundled?
So instead of these big monolithic systems,
Okay.
you're starting to see more specialized components.
Okay.
And then you combine these components to create more tailored solutions.
Oh, it's like having a modular system
Yeah,
where you can pick and choose the best parts.
Yeah, pick and choose the best components for your specific needs.
Does the book give any like specific examples of this?
Yeah, it explores topics like data flow programming,
Okay.
end-to-end event streams,
Uh,
and the role of application code
okay.
for data management.
So it's a vision of the future where things are more adaptable,
Yeah.
more scalable, more resilient,
Yeah.
but also probably more complex
Yeah, definitely more complex.
and requiring more specialized knowledge.
Absolutely.
Okay. So it sounds like the future of data systems is going to be both really exciting
Yeah,
and also really challenging.
definitely.
But before we get too carried away with the future,
Right.
the book brings us back down to earth a little bit with a discussion of correctness in data systems.
Yeah,
And it really emphasizes that, bugs and errors are inevitable,
they are.
even with the best designs.
Absolutely.
So why is this such an important point to consider?
Well, because even small errors in data systems can have massive consequences,
Yeah.
especially when you're dealing with, sensitive information
Right.
or critical applications.
Right.
So the book really emphasizes the importance of things like testing monitoring and even formal verification
What?
to make sure that our systems are behaving as expected.
So it's kind of like having multiple layers of quality control
Exactly.
to try to catch these bugs before they cause any real harm.
Yeah, you want to be proactive.
Yeah.
You don't want to wait until something bad happens.
Right. Be proactive rather than reactive.
I think exactly.
Okay. But, testing individual components can only get you so far.
Right.
Right. What about like the overall flow of data
Yeah.
through the system?
So that's where the concept of end-to-end correctness comes in. And the argument is that we need to think beyond just testing individual components in
Yeah, yeah.
isolation. We need to think about that entire data flow
Okay.
from input to output.
Right.
And we need to make sure that the system as a whole
Yeah.
is producing the correct results.
So it's like making sure that all the links in a chain are strong,
Exactly.
not just like
Not just one.
individual links.
Yeah.
Does the book give any examples of how to actually achieve this?
It does. It talks about techniques like idempotence,
Okay.
which means that an operation can be executed multiple times
Yeah.
without changing the result,
Okay.
and then using unique request identifiers
Okay.
to track data as it flows through the system.
So those are like ways to kind of build in those extra safeguards.
Yeah.
Okay.
Make the system more resilient to those errors.
Cool. So the book also talks about enforcing constraints in data systems.
Yes.
Things like data uniqueness or referential integrity. Can you explain what those are
Yeah.
and why they're important?
Yeah, so constraints are essentially rules
Right.
that help ensure data integrity.
Okay.
So they prevent invalid data from
Okay.
entering the system,
Oh.
and they help maintain consistency.
Got it.
So uniqueness constraints
Yeah.
make sure that certain values like a user ID.
Unique,
Right.
referential integrity constraints
Yeah.
ensure that the relationships between tables are valid.
Okay.
So you're not going to accidentally delete a record
Right.
that's referenced by other records.
So constraints are kind of like having a bouncer
Yeah.
at the door of your database,
Yeah.
making sure that only valid data gets in.
Only the good stuff gets in.
Okay.
Yeah.
But enforcing these constraints in a distributed system
Yeah.
can't be easy.
It's a lot more complex when you have data spread across multiple servers.
Right, because you have to coordinate
Yeah.
across all those different servers.
Exactly. And so the book gets into, the complexities of enforcing those constraints
Oh.
in a distributed environment. It talks about techniques like consensus algorithms and distributed locking
Okay.
to ensure that those constraints are enforced consistently.
So it's like having a team of bouncers working together
Working together
to keep the data safe.
to keep the bad data out. Okay, cool. So, even with the best software designs,
Yeah.
we can't ignore the fact that hardware can fail,
Absolutely.
right? Hard drives fail and all sorts of stuff.
Yeah.
So how does the book kind of address that issue?
So the book takes this very pragmatic approach.
Yeah.
And it acknowledges that, hardware failures are a reality
Yeah.
and we have to be prepared for them.
Yeah.
So it encourages us to design systems that can tolerate these failures.
Okay.
So using techniques like redundancy,
Uh-huh.
where you replicate data across multiple devices.
Right. So if one drive fails,
Right.
you've got another copy
You got a backup.
somewhere else.
And then you have things like error detection codes
Right.
that help you identify and correct data corruption.
So it's like having that spare tire
Yeah.
for your data just in case you get a flat.
Exactly.
But the book goes even further than that.
It does.
Right? It doesn't just focus on hardware failures.
Right.
It also wants us to think about data integrity
Yeah.
from a much broader perspective.
From a more holistic perspective.
Mhm.
So thinking about things like software bugs and human errors.
Because even like the most carefully designed system
Right.
could still have those issues.
Absolutely.
So does the book talk about how to address those as well?
It does. It talks about techniques like checksums,
Huh?
data validation auditing to
Good.
help you detect and correct data corruption.
So it's like having a detective on the case,
Yeah.
always looking for clues that might indicate a problem.
Always looking for those subtle signs
Okay.
that something's not quite right.
So as we kind of wrap up
Yeah.
our deep dive into designing data-intensive applications,
Yeah.
what are some of the like key takeaways
Okay.
you want listeners to remember?
I think the biggest takeaway is that building these systems,
Yeah.
these reliable, scalable, maintainable, data-intensive applications,
Yeah.
it's a really multifaceted challenge.
Yeah.
And it requires a deep understanding
Yeah.
of both theoretical principles and practical considerations.
Right.
There are no easy answers.
Yeah.
And often the best solutions involve trade-offs.
And it's a constantly evolving field as well.
Aggressively.
So what we've learned today
Yeah.
will probably change and adapt.
Deal.
So what advice would you give to listeners who want to stay ahead of the curve?
I would say stay curious,
Yeah.
keep learning,
Yeah.
and embrace the challenges of
Yeah.
building the next generation
Yeah.
of data systems.
Cool. Well said. And for our listeners, we hope this deep dive has given you a really solid foundation to start exploring this
Yeah.
amazing world of data-intensive applications.
It's a fascinating world.
It is. And be sure to check out the book,
Yeah.
Designing Data-Intensive Applications,
By Martin Kleppman.
for a much more in-depth look at
Yeah.
all the stuff that we've talked about today.
Yeah.
And until next time, keep diving deep.
Yeah.
It really is. And it seems like, this unbundling trend, it's going to offer a lot of flexibility.
Yeah.
Potentially, a lot more efficiency. But it's also going to require, a lot more careful design and integration
Absolutely.
to make sure all these different pieces
Yeah.
work together well.
It's like having a more complex orchestra,
Yeah.
right? You need
More instruments to tune.
Yeah, you need more skilled players to make sure everything sounds good together.
Right. You don't want it to just sound like noise.
Yeah, exactly.
So the book also talks about the idea of data warehousing.
Yes.
So can you explain what that is and how it kind of fits into this whole picture?
Yeah, so data warehousing is basically about creating a separate copy of your data,
Okay.
specifically for analytical purposes.
Okay. So it's not the same as
Yeah.
your like operational database.
Right, it's a separate system.
Okay.
And it's optimized for those kinds of analytical queries.
Got it. Yeah.
So, things like, trying to understand trends over time
Mm-hmm.
or identifying patterns in your data.
So why do you need a separate system for that? Can't you just do that with your regular database?
You can in some cases, but traditional databases are really optimized for transactional workloads.
Okay.
So those are, like small updates and reads
Yeah.
that are happening all the time. But analytical queries,
Right.
they often involve scanning large portions of the data.
Right.
And those can be really slow and resource intensive.
So it would slow down like the main app
Yeah, exactly.
if you tried to do it there.
Right. And so a data warehouse lets you run those analytical queries
Right.
without impacting the performance
Got
of
it.
your operational systems.
So what are some common technologies that are used for building data warehouses?
So the book talks about, traditional relational databases,
Okay.
but it also mentions some newer technologies
Yes.
like column-oriented databases,
Mhm.
which are specifically designed for analytical workloads. And then you have cloud-based data warehousing services,
Yeah.
which are becoming increasingly popular.
Right, because you don't have to manage the hardware.
Exactly.
Yeah.
Right? They handle all the infrastructure for you.
So it's like a more scalable and cost-effective way to do it.
Absolutely.
Cool. So the book also delves into the world of ETL, which stands for Extract Transform Load.
Yeah, it's a big part of data warehousing.
So what is that all about?
So ETL is the process of getting data from your various source systems,
Okay.
cleaning it up, transforming it,
Okay.
and loading it into your data warehouse.
Okay. So it's like taking raw ingredients
Yeah.
and turning them into a delicious meal
Exactly.
that's ready to be analyzed.
It's a very apt analogy.
Okay. So the book talks about different approaches to ETL,
It does.
right? Like, what are some of the things that people should be thinking about when they're designing these ETL pipelines?
Well, one important consideration is data quality.
Okay.
right? You want to make sure that the data that you're putting into your warehouse is accurate and reliable.
Yeah, because if you have garbage data,
Exactly.
you're going to get garbage results.
Garbage in, garbage out.
Right, exactly. So how do you make sure that the data is good?
So the book talks about various techniques for data cleansing,
Okay.
data validation, data enrichment. And then another important factor is performance.
Okay.
These ETL pipelines can often involve processing very large amounts of data.
Right.
So you want to design them
Right.
to be as efficient as possible.
So it doesn't take like days.
Yeah, you don't want it to be a bottleneck in your data analysis process.
Right.
So the book talks about different ways to optimize these pipelines.
Okay.
Things like using parallel processing, distributing the workload across multiple machines.
So it's kind of like applying those same principles of scalability that
Exactly.
we talked about earlier,
Yeah, the same principles apply here
but just to like a different part of the system.
to a different stage of the data life cycle.
Okay.
Okay.
Cool. Well, as we've been talking about all of these different concepts and techniques,
Yeah,
it's clear that this is a very complex and challenging field.
it is.
So what advice would you give to someone
Okay.
who's just starting out? They're interested in learning more about data-intensive applications. Where should they start?
Well, I would say, first of all, don't be intimidated.
Yeah.
It can seem overwhelming at first, but there are a lot of great resources out there.
Yeah.
Obviously, this book that we've been talking about
Yeah, this is a good place to start.
is a fantastic resource.
Yeah.
It covers a wide range of topics.
Yeah.
It's very well written. It's very accessible. There are also a lot of great online courses and tutorials,
Cool.
and then just get your hands dirty.
Yeah.
Try building something.
Yeah, just experiment and play around.
Exactly. You learn best by doing.
Totally. And don't be afraid to ask questions.
Absolutely.
There's a really great community of people who are working in this field, and most people are happy to help.
Very supportive community.
Yeah. Well, that's great advice.
Yeah.
And I think that's a perfect place for us to wrap up
Yeah.
this deep dive. So thank you so much for joining us today.
My pleasure.
And to all of our listeners out there, we hope you enjoyed this exploration of the world of data-intensive applications. And until next time, keep diving deep.